Okay, let's talk about platform engineering, right? Something everybody wants to talk about when they're not talking about AI.
There you go.
So, in both of our cases, we started like normal developer, right?
Yeah.
What do you do? You kind of write getters and setters in Java or whatever.
What did you do? Like, what was your first thing, like developing stuff? What kind of software did you?
Pascal,
that's good. Yeah.
It's not good.
It's so old that I don't even remember. Yeah. So in my case, I started like as a Java developer, right? And creating Java applications professionally, I got used to the idea of I create my applications, then somebody will package my application and deploy it, or maybe on an application server. That's something quite old right now. We didn't have containers at that time, but we had that idea of a platform as this application server where our applications will run. And that changed drastically over time, right?
Yeah, and we started, or at least I started over time kind of being more focused on how to help other people do stuff than me doing stuff. That's being a manager without having anybody who reports to you.
Yeah.
And the first platform of sorts that I built, anybody can guess what was used? The oldest platform building tool in the world?
The oldest.
No?
No guesses?
Hudson? Anybody knows what is Hudson? Ah, there we go.
There you go.
There is somebody older than 35. Cool.
There you go.
Amazing, right? So and when you think about it, Hudson is a platform, right? No sane person would use it today, or Jenkins.
Yeah.
It had a nice UI, you can click buttons, you can automate things, you can execute things, you can do all the things that we do today with the platform, right? And then came something very, very different, right? We got Docker, containers. You're not building platforms only with containers, but that was a critical piece because we can suddenly package something and run something and so on and so forth.
As a developer, it helped me to say, you know, I don't need to package my Java application as a Java application itself. I can pack it as a container, and somebody else who doesn't know about Java can run it anywhere. And for me, that was kind of like a big moment where I can say, you know, now I can run something. I don't even need to know what's inside. And I think that helped a lot in the evolution of what we know today as platforms, right?
Yeah. And then we run into issues with Docker very, very quickly, probably almost the day it was released. And those issues is, okay, but how do we run now this at scale, right? How do we run containers at scale? How do we figure out what is running where and so on and so forth? We got 57 different orchestrators. Most of them you never heard of, but the one that sticks, it's Kubernetes, right? We got Kubernetes, and that became a base on top of which we build everything, right? Whatever you're doing, it's built on top of Kubernetes, unless you're using ECS, and then you're terribly wrong.
Yes, right? that can happen, right? For me, it shouldn't, but like it happens. So for me, kind of like being a Java engineer, when I started using Kubernetes in 2015, I quickly realized that for no matter the programming language that you were using, as a developer, you will need to start learning how to use Kubernetes. Because at the end of the day, your applications and the application architecture needs to reflect and needs to be kind of like adapted in some sort of way to run on top of Kubernetes. So since then, basically, same path as Viktor, trying to help other teams to use these tools, no matter if you're using Java or if you're using .NET or if you're using Node. How do you package your applications, put them on top of Kubernetes so you can actually run those applications at scale? For the Java community itself, that was a huge paradigm shift because we were used to do things in the Java way. I'm pretty sure that .NET people did the same for .NET applications. But the journey so far over the last 10 years of Kubernetes has been pretty interesting. First, how do you run Java inside containers, and then how do you scale up those applications into a Kubernetes deployment? So kind of like interesting journey that we have been, right? But something happened, right? Like we kind of like decided that Kubernetes is the base layer for everything, right?
It's decided, exactly.
Yes.
And the point of the story until now is that whomever is building platforms now, internal developer platforms, you're not doing anything new. We've been building platforms for decades, right? Kind of in just different forms and ways. You might have been making it, if you're old enough, scripts. You maybe made some web UI. You maybe made this or that. Maybe used Jenkins. And then you cannot sleep at night anymore because of the traumas you had from that, right? But it's nothing new, right? This is just the term platform engineering is something that was coined like a year, 2 years ago, something like that. The concepts are the same.
And let's be clear, like these platforms that we are building are cloud-native platforms, right? Because we are building them on top of something like Kubernetes. So they are just not like normal platforms that like the ones that we were building before with Jenkins or even with scripts. These are just following some very specific architectural patterns.
And that leads us to where we are today, right? And where we are today is that the pattern how to build the internal developer platform is well known. There is nothing to figure out, right? The high-level architecture has been in operation for a long, long time. And every single platform that is not internal platform is using that. All the public platforms are using the same patterns, like AWS, Azure, Google Cloud,
Alibaba Cloud.
Alibaba, whatever else you're using. Same pattern always. And that pattern is relatively straightforward, right? You have service owner, that's a person, that's a team, or a company, and it's creating services that you can consume, right? You have service consumers, that's everybody else. That's people, that's you when you go and say, give me EC2 instance in AWS or whatever in Alibaba or in Azure. That's you, right? That's a consumer of those services. We have services themselves. Some people manage those services. Other people consume those services. And this is important for the rest of the story. Services are always consumed through an API. Always, 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 right? Doesn't matter. You might think, oh, no, I'm consuming services by running Terraform. No, Terraform is talking to that API, right? It's always API.
And I think that that's kind of like one of the main changes, right? Like the fact that now we have formalized how do we build platforms putting APIs first. So the APIs needs to be there for this to be easily consumable by other teams without knowing how all those services are wired up.
Yeah, and on top of APIs, and the names can differ, there are controllers, right? Those are the processes in the control plane of the platform you're using that are assuring that things are happening. Oh, somebody asked for this. Yep. Let me do that. Something is failing. Let me start it, so on and so forth, right? Those are the processes in your platform that are managing the services that you created, the instances of those services that you created. Now, the new thing, the only thing that changed since long, long time ago is that everybody was building this using this pattern in whichever way they were doing it. And today we are all building the same pattern on top of Kubernetes because nothing else makes sense today, right? And the major question you need to ask yourself when you're building a platform is that, are you going to use third-party services as your services, or you're going to build your own? And the answer in vast majority of cases is yes. To both.
Both.
Right?
Yeah, yeah. And that's why we have like a very vibrant community in the CNCF landscape, like tons of different projects.
Madness.
It's not vibrant. It's
this is like, insanity.
That's insanity. Yeah, both. Yes, to both, right? Yeah. So tons of projects that you can choose from that basically push teams to evaluate these projects and figure out kind of like what are the problems that they are trying to solve, and then pick the right solution for that problem. And that takes us again to where we are today, like trying to figure out how do we manage all this complexity and how do we create platforms without starting from the scratch, right? Because just creating tools for every single problem that a platform team might face just will take you forever, right? Which take us to kind of like the next path in both of our careers, right? So we started as developers, then we started building some sort of like helper for other people to be more productive. And then we jumped to work more like in the Kubernetes space. So I started working back then in 2018, I think, in the Knative project, right? So I started working with Knative for scaling. Because like in my mind, when I thought, okay, I've been working with Kubernetes and Java for a long time, I decided to say, okay, now if I want to help more people building platforms, they will need some sort of scaling solution. Kubernetes brings kind of like the scale to zero capabilities, but also the simplified deployment mechanisms for teams to use. You define a very simple YAML. This is my container. You run it, and it's serverless. It's a pretty good tool to just simplify adoption for platform services. Imagine like if you're doing something like Google Cloud Run, where you just provide a container and they will run it, you can create something like this with Knative on top of Kubernetes. So I spent a couple of years working on the Knative project saying, this is a good thing to move things forward. But then I realized this is kind of like a basic core capability of every platform, right? So if you're building a platform, it's really likely that you need this. And it's becoming kind of like standard in general, like these kind of tools like Knative and also the tool that you were working on, right?
Or Argo CD or anything else. The point really is that you start with some third-party services in your platform that do some generic work. So this is how we synchronize things. This is how we deploy applications. With Knative, this is how we do this is how we do that, right?
Yeah.
You start with what exists because you don't want to waste your time. And then you start progressing in making it your own, right? Making it very, very specific for your use case, for what your company needs, for what other people in your company need, right? And these are just few examples, but
yeah. So and that basically meant that after working in Knative for 2 years, I said, okay, let's go a little bit up to the stack. Now I want to help developers to consume complex infrastructure. So a couple of years ago, I joined the Dapper project and started working quite aggressively in that space because I believe that tools like Dapper that expose APIs to developers to consume complex infrastructure across cloud providers, it's kind of like it's a centerpiece when you think about like how do I enable more teams of developers that are building cloud-native applications inside like of a platform team? And the same for you, right? Like you started working at Crossplane.
Yeah, I started working with Crossplane simply because Crossplane is one of those tools that allow you to build your own stuff, right?
Yeah.
Instead of using generic. In this case, that own stuff means primarily two things. How do you create those APIs? How do you create your own APIs that people can use to consume? In Kubernetes, that's called CRDs, custom resource definitions. And how do you create those controllers that you saw earlier that will intercept those requests to the API and do something like, oh, I want a database. Cool. What is a database? Yeah. I don't know. If it's AWS, that's 75 subnets and 3 VPCs and an infinite amount of storage and one PostgreSQL RDS and 7 database schemas, and insanity just continues, right? But allows you to create those controllers that will manage all those resources without the user, the consumer of the service, having to completely lose their mind by going through those details.
Kind of interesting between kind of like Crossplane and Dapper, they both provide building blocks so teams don't need to build these services by themselves. In Crossplane, it's pretty clear. You're not creating your own controllers. Like Crossplane is solving that for you, right? It's not pushing teams just to go and create more software. And basically, that's why we had like a blog post back in a couple of years ago about like how do you put things together, right? Like how Dapper allows you to consume things that you are provisioning with Crossplane, because we believe that it makes a lot of sense. But since then, tons of things have happened, right?
Yeah.
And it takes you to that place.
And basically, once you figure it out, once you figure out, okay, this Kubernetes, I'm extending it with third party, everything is accessible through APIs, I'm creating my own API endpoints, I'm creating my own controllers, I'm making it my own, specific to my organization, only then. And everybody makes the same mistake. Everybody starts from the other side around. Only after you do all that, you can start thinking about the user interfaces. Yes. Okay, so how do people talk to that API, right? If you ask me, everybody should be using only CURL. People don't like that. That's why we have dashboards and GitOps and observability and all the other user interfaces people need. And then the pattern becomes, follows the same pattern, right? Your consumers are talking to that user interface or talking directly to the API. You don't care because your job is not to create user interfaces, at least not the primary one, but to create those APIs. And those APIs, those controllers in that platform, in that Kubernetes extended platform, then speaks to other Kubernetes clusters and does things over there, and it speaks to cloud and does things over there, and speaks whatever else you might be having or not having, right? And that box becomes what we call control plane, right? That's what, and just to be clear again, every single platform in a world that is worth using uses the same pattern. Everybody has a control plane that controls everything you have, and communicates back to that control plane so that you can understand what's going on, what just happened, why did it happen, and so on and so forth.
Just to clarify there, like the difference between control plane and the Kubernetes clusters.
So I wasn't clear, and you need to clarify.
No, I just want to say that like the boxes there in the control plane are not applications; those are the the platform services, and your applications will run on managed Kubernetes clusters. That's what the control plane is doing, basically. Yeah. And again, like what we have seen so far in the last few years, 2023, I published a book titled Platform Engineering on Kubernetes. What I did inside that book is just to show you a combination of these tools just to create some example platforms. And what I've seen since I published the book in 2023 is, a bunch of blueprints. Right? I can have this, yes. So a bunch of blueprints. One of those is the backstack. Basically, again, showing you how to combine different projects to get something to start with, right?
What is a back?
What is a back? So back is just 4 projects: Backstage, Crossplane, Kyverno, and Argo CD, in the wrong order, but I will get it at some point. But again, the idea here is they have combined the projects. They give you kind of like a starting point, so you don't need to spend time figuring out how to combine them together. And they clearly specify what this platform or this example blueprint of a platform will do for you. Another example is Kanui, coming a little bit more from the AWS side of things. This is a much more complex beast. It's a little bit bigger, but it allows you to swap components out. They have defined the core capabilities of platforms like infra as code, continuous delivery, identity access, developer portal, and a bunch of other things. And they allow you to say, well, I want to use Argo CD for continuous delivery, for example, right? Or I can swap it for Flux if I want to do that. You have Crossplane, you have Terraform, you have a bunch of different things in there. I think that this is, again, it's extremely important as a starting point, so you don't need to figure it out if you're starting to create your platform from scratch. The Cushion stack is another extremely good example because they bring more components into the mix. I highly recommend this because this is just a little bit more based on how to aggregate data so we can query in real time what's happening into our platform, but they also have a platform orchestrator and a bunch of other things that are extremely, these are the things that kind of make sense for you to build, and companies used to build this internally. So the more that we can get from third parties, we can start faster to build our platform, right?
So yeah, the point of where we are today is really that architecture is known, high-level architecture, don't try to reinvent the wheel, build a control plane, build API, build controllers that manage your services, let people consume that API any way they want, everybody's doing the same. No need to figure out different pattern. The tools change.
Yeah, the pattern stays the same.
The pattern is the same, at least so far.
Yep.
And that brings us to the future, where the pattern still stays the same, but the tools are going to change drastically.
Changing a little bit. But before the future, or this is also part of the future, is that CNCF is working on these platform engineering certification programs. And for me, the only reason why I want to mention this is because this basically means that we are coming to a point where we all understand what platform engineering is. Like the things that we just explained are becoming kind of like common sense in the industry, and we are just creating the material just to make sure that we are speaking the same language, right? But let's talk about what's happening now with all the craziness in the world.
Oh, everybody knows what's happening.
Of course, AI. Yeah. We can just not leave this stage before like talking a little bit about AI, right? That's what it is, and that's yours.
So yeah, so if you take now where we are right now, or where we were until very recently, same diagram what I was speaking to before, but what is changing? First of all, we got LLMs, basically models that contain the whole internet, everything ever done on this planet, and we are replacing quite a few things. One of the important things is that how people communicate with those platforms, right? They are requesting things in natural language. I want a database. Give me a database. Where is my database? Yeah. Right? You start freaking out and putting exclamation marks when you speak with that something. Those services that we have before will slowly start, or fast, being replaced with agents, right? Instead of service that is predefined, very rigid and does only one thing and does it well, we are going to start replacing them with agents that will be more intelligent and be able to leverage those LLMs and to leverage also MCPs so that they can perform actions required to fulfill users' needs, right? So you ask me something, give me a database, I ask you back the questions, okay, but which type of database, where do you want it, and so on and so forth. I will consult LLMs to get all the information I will ever need to perform those tasks. I will talk to some tools to do something through MCPs, Model Context Protocol. And finally, or during that process, I will go back to APIs of the destination, being the AWS or some other Kubernetes cluster or whatever it is, and just do the operations I need to get what you asked me to get, right?
That's correct.
And that leaves me.
Yeah, so, and I think that's kind of like, right, that's where we are heading, right? Like, that's definitely the place that we are heading. But we need to think about, like, okay, what kind of challenges are we facing when we want to run these platforms on top of Kubernetes? And what I've seen kind of like in the last couple of years is like a specialized tool to solve multi-cluster challenges, right? What we were saying before is that you will have a control plane, probably multiple Kubernetes clusters where your applications will run. That basically puts you in a position of you need to master how do you manage and, and create new Kubernetes clusters. So what I wanted to do here is just highlight 3 tools that I've seen going very, very popular very fast. The first one is Queue. Queue will allow you to schedule, jobs across multiple clusters in an efficient way. Scheduling jobs is not that complicated, but when you want to do it across multiple clusters and efficiently, that's a really hard job to solve, and you probably don't want to spend time doing that. You can just choose Queue and just get it done. The other one is KCP. If you have multiple clusters, it kind of makes sense to have an API to access them all and to schedule workloads across multiple clusters. For multi-tenancy, kind of make also a lot of sense. Like defining how to do multi-tenancy on top of multiple Kubernetes clusters shouldn't be something that a company, like an organization, needs to spend time on. There should be something out of the box that can help me with that. KCP is another project that it's pretty popular. And as I mentioned before from the Cushion Stack carport, right? Like if I want to do smart queries against multiple clusters and what's happening in real time, I just need a component to do that for me. Again, I just don't want to spend time in my organization to define how to do that. And when you think about that, like you start thinking about, okay, so if we want to bring AI capabilities like LLMs or even interacting with LLMs to our platforms, how do we do that like using kind of like what we call now the platform engineering way? Well, there are a couple of things. Like Viktor, you mentioned agents before, right? Whenever we have agents or whenever we want to interact with LLMs, there are a bunch of things that are extremely important. And I consider like 2 main aspects. The first one is the developer experience. How do I access these LLMs? First, I can expose like an API that abstracts away the complexity of connecting to the LLMs. So users kind of like just send a request to an API and that's pretty much it. But the second aspect that I believe it's a little bit more important for platform engineers is like all the governance aspects on how do we access these LLMs, how do we make it secure, how do we make it observable, and how do we make it reliable, right? Something like that the Dapper project is doing is exposing kind of like the conversation API that basically abstracts how do we communicate with LLMs, but also brings all the governance aspects to it as well. And then the next question is agentic frameworks. This is a very complicated topic in my opinion because we have seen so many frameworks in that space over the last year, right?
Half a year, 4 months.
4 months. How can we keep track of the number of frameworks? It's just impossible, right? In Python, you probably have like thousands already, right? But when I think about agentic frameworks, I think about 2 things. We were talking about platforms. So there is a project that it's called K-Agent that basically will create agents that can monitor and give you insights about what's happening inside your clusters. So if you're using Crossplane, or if you're using Dapper, or if you're using Istio, you have agents that basically will look into the resources and then will be able to answer questions about this. For platform engineers and for troubleshooting, this is kind of like amazing. But then you start thinking about, okay, how do you build business agents that do like business operations or business like application related agents? And that's where the Dapper Agents project sits on top of all the Dapper building blocks. If you haven't checked this out, there's a blog post in the CNCF that was published a month ago or so about how this project is basically relying on the things that we already have in the Dapper project to run agents in production. So I 100% recommend that if you haven't seen that. And that takes us to pretty much the conclusion of our presentation after like a long
As if we
journey.
have one.
Yes. Well, we don't know what we are doing with AI just yet. I guess that we are all trying to figure it out. And we are just looking into this space to see where it goes. We know that governance is important. We know that observability and security are extremely important. But we can actually not build this on our own in isolation, right? We have learned that from lessons at Crossplane, lessons at Dapper, Knative, Argo, right? If we build all these solutions as like a community, like collaboration across companies, we are actually going to create a solution that other companies can use and that they can help us to enrich in functionality. I keep thinking that when you're building a platform for your company, you actually need to go out and check what other companies are doing, probably in the same industry or in different industries, so you can actually start saving time when you build your own platform and just make it there faster, right? Do you want to add something else on top of that?
No, I guess we have 5 minutes for questions.
I think that that's pretty much it. Thank you so much. Yeah. Questions?
Anybody?
Don't be shy. Come on. I know that Viktor seems intimidating there, but we have a question there. Microphone there, yeah.
Thanks, guys, for this talk. Do you know something for AI tools for debugging platform, Kubernetes platform?
So even right now, I don't think that there are many really good specialized tools for that. But most of the agents you would normally do are pretty capable of doing that, right? If you use something like Claude Code, for example, just from a terminal, if you give it access to the cluster, either directly, kubectl, or through MCP, Kubernetes MCP, this or that, they're pretty capable already of debugging, right? And if on top of that you connect it with some metric storage like Prometheus or whatever you're using, then the results are already amazing, right? What I'm looking for, that's where we are, and on-demand debugging is already pretty good. Where I think that we will be going is to leverage, first of all, to start putting those agents inside Kubernetes clusters, right? And start hooking them into Kubernetes events, right? Yeah. So instead of, the silly thing would be I can run in a loop and every minute kind of check what's going on. But if we hook them to Kubernetes events, and then, hey, whenever some special events or events of certain types are happening, call this agent, propagate the information to the agent goes to the cluster and figures out, okay, so what is the effect of that event that just happens, and can provide you with the information proactively, right? Now, whether that information is then sent back to, actually, from that information, there are two things we can think about, right? One is very scary of those two things. One is, okay, so I figured out that there is something wrong. I send you a message on Slack or email or whatever you're using. That's probably how everybody will start. But then where we're going from there is, okay, so I received this event, I evaluated the cluster, I figured out what's going on. Can I, in certain cases, if not always, execute certain actions to mitigate that issue, right? And the main problem there, as I see it right now, is not necessarily agents. Agents are extremely capable. But how do we give guardrails to those agents, right? So because if I just put Claude Code in my cluster, that's an easy part. But how do I control what it is doing and no, right? And that's the work that is still ongoing or pending, right? And it probably will involve some heavy usage of certain rule sets, kind of like, okay, so within this organization, you're capable of doing anything in a world, but within this organization, this is how we do things, this is what we never do, and so on and so forth. So I think the next phase is really creating, not necessarily in the agent space, but creating those rules. The same rules like, when you joined your company the first day, probably the first things that you were taught, okay, here, this is how we work. This is what we do, this is what we don't do. we need a way to propagate that information to agents.
And then those rules are pretty much like the specialized tools that you will have for troubleshooting, right?
Yeah, special tools, but also kind of, hey, we never use this region in AWS. We always work in that region. Never touch a database, but if the application is down, it's okay to restart and so on and so forth, right? So I think that the major challenge now is translating verbal knowledge within a company, or sometimes wiki knowledge in a company, into something that those agents will understand.
Yeah. Long answer, but
very
complete.
Yeah, I'm buying myself time.
Yes.
Maybe we have one more?
One more? Yes.
Well, I'm sorry.
Thank you. I know this is a cloud conference, and the talk was mostly about the platform in relation to the public cloud and how companies use it. But increasingly, the number of companies that are using or require their own infrastructure because of their compute needs. So, the big technology companies in the US or even Bloomberg, they're using their own infrastructure. Yep. Do you see the same type of innovation in dealing with infrastructure as there has been with platform-specific software? So, for example, with like Kubernetes, but in relation to hosting your own infrastructure? And if not, how come there's not the same level of innovation there?
So I think it's exactly the same. I don't see a real difference, assuming that your own is done right. And by right, what I mean is that it doesn't matter whether we're talking about controllers doing something or agents doing something. The key always is there an API on the end of that something?
Yeah.
Right? Now, if you say, I have my own infrastructure, it is managed by me SSHing into each individual server and doing something, then my suggestion is to change the job.
Just put
right?
an API. Yeah,
now,
just put an API.
If you're talking about API, really, neither for controllers nor for agents makes much difference whether that API happens to be AWS or VMware something, or whatever you have, right?
Yeah.
The key is really in APIs. Can something talk to something else through an API? If yes, I see no difference, really. I mean, there is actually a difference. Difference is that many of the tools always start with AWS, Azure, Alibaba, Google Cloud. So you might need to wait longer. Either you need to wait longer until the solution for something else comes, or you need to start building yourself that something, right?
Yeah.
But the logic is the same, the effect is the same.
Good stuff. I think that we are done. Yeah.
Thank you so much.
Thank you so much, folks. Adios.